Hey everybody. We've been working on solving equations with variables on both sides for the last couple days in class and on the homework. Today we're going to take a look at how we can use these equations to model situations and then solve those situations to find the answer. Let's take a look at our first example here. We have a hot air balloon is 10 feet above the ground and rising at a rate of 4 feet per second. A second hot air balloon is 120 feet above the ground and descending at a rate of 6 feet per second. When will the two balloons be at the same height? As usual, with this word problem, I'm going to use the star process. I'm going to make sure I underline what we're looking for. When will the two balloons be at the same height? So we need to use a variable to represent this. I can use t since we're looking for time. Now we want to make sure we put a box around any relevant information 10 feet above the ground. That's important. This is for the first balloon. And rising at a rate of 4 feet per second. Our second balloon is 120 feet above the ground. And descending at a rate of 6 feet per second. So it's all good to know. Now, we can translate our statement here into a mathematical equation. We know that they're going to be at the same height. So we know that the height of the first balloon is going to be equal to the height of the second balloon. Now we just need to represent the height of the first balloon. I know it starts 10 feet above the ground and it's rising at 4 feet per second. So we can add 4 times the number of seconds, t. T is our measure of time in seconds. 10 plus 4t gives us the height of the first balloon. Our second balloon starts at 120 feet, but this one is descending at a rate of 6 feet per second. So its height should decrease by 6 feet every second. So this is going to be minus 6t. Now we have an equation that we can solve. I'm going to eliminate this negative 6t here by adding 6t to both sides. That's going to give me 10 plus 10t equals 120. Now I need to subtract 10, and I get 10t equals 110 divided by 10, and I get t equals 110 divided by 10 is 11. So 11 seconds, after 11 seconds, these two balloons will be at the same height. Alright, we're going to take a look at just one more example here, but this one is kind of tricky, so follow along closely. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of the used cars sold? So we need to underline the question here. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? So it's looking for the number of years. So we can use y to represent that. Y equals years. Now we can box the important information that is going to help us find that answer, find y. I know that we sold 78 new cars this year, and we sold 67 used cars this year. The number of new cars sold has been increasing. So new cars sold has been increasing by 6 cars each year. And the number of used cars sold by the dealership has been decreasing by 4 cars each year. So that's going to help me set up my equation. I know the number of new cars is going to be 78, because that's how many we sold this year, and that number is increasing. The new cars is increasing by 6 cars every year. So that's going to be 6 times the number of years. And remember, in our question, it says, in how many years will the number of new cars sold be twice the number of used cars sold? So on the right here, we're actually going to take the number of used cars and multiply it by 2. And the used cars we can represent by starting with 67, because that's how many we sold this year. But the number of used cars has been decreasing by 4 cars each year. So we're actually going to subtract 4 times the number of years. Now once we have this equation, we know how to solve this. We can distribute the 2. We wind up with 78 plus 6y on the left, and that gives us 134 minus 8y on the right. Make sure you distribute to both terms. Now I'm going to eliminate this negative 8y by adding 8y. It's going to give me 78 plus 14y equals 134. After those 8y's cancel out, subtract 78. I get 14y equals, let's see here, we're going to have to borrow. It's going to be 2. That'll be 14 minus 8 is 6. Borrow from that 1. 12 minus 7 is 5. And we divide by 14. And we get y equals 56 divided by 14 is 4. So in 4 years, the number of new cars will equal twice the number of old cars.